Okay, let's dive into this. Picture this scenario for a second. It's 2 p.m. on a totally normal weekday. Millions of people are glued to their couches, deep into streaming their favorite Netflix shows. Thousands of companies are processing crucial payments. Food is being ordered, flights are being booked, and businesses across the globe are just humming along, all powered by AWS. Then, without any warning at all, a massive earthquake strikes. An entire AWS data center suddenly loses power. The servers go completely offline, the lights go out, everything inside that massive, high-tech building just stops.
Which brings us to a massive, incredibly high-stakes question. Does the internet stop? Just take a second and really think about that. Do Netflix, Amazon, Spotify, your mobile banking, and thousands of vital food delivery apps just instantly disappear into the digital void? The answer, amazingly, is a resounding no. You can totally breathe a sigh of relief. But how is that even possible? How does a physical building completely shutting down not drag the rest of the digital world down with it? Well, in this explainer, we're going to unpack exactly how AWS pulls off this unbelievable magic trick to survive a catastrophic physical disaster.
Now, what's really interesting about this slide is how it shatters a very common myth. Most people imagine the cloud as just one giant noisy room full of blinking computers, like a single massive brain. But the reality is completely different. Think about it like this. If you were storing your absolute most precious physical valuables, you wouldn't shove every single thing into one gym locker, right? No way. You'd keep copies in different, highly secure places. That is exactly how AWS designs its infrastructure. It is definitely not one single building. It's this incredibly complex, globally distributed safety net.
Let's start by looking at the basic building block, the data center. Simply put, this is a massive building filled with thousands of incredibly powerful computers. They store files, run websites, train complex AI models, and process literally billions of daily requests. It's an absolute marvel of engineering, but it has a fatal flaw. A single building can easily succumb to an isolated disaster. We're talking floods, local power outages, human errors, or, our ongoing 2 p.m. earthquake scenario. If absolutely everything is in one building, and that building goes down, you have a massive problem on your hands.
So the engineers at AWS looked at this and asked, okay, what if this entire building just disappears? Their brilliant solution? Availability zones, or AZs. Instead of building one enormous mega data center, they built several highly independent data centers relatively close to each other. Think of them as independent superhero headquarters, all located in the same city. But here is the real secret sauce. They do not share any vital resources. Zero. Each headquarters has its very own electricity grid, its very own cooling systems, its own networking cables, and its own physical security.
Let's bring back our earthquake. It hits hard, and Availability Zone A goes completely offline. Every single server inside shuts down instantly. But because of this entirely independent setup, it's basically just like a teammate leaving a sports match. The remaining teammates, in this case Availability Zones B and C, instantly pick up the slack. They just keep playing the game without skipping a single beat. Users sitting on their couches watching a movie literally never notice a thing.
Now that usually brings up a deeply personal question from people. Okay, sure, the network is up, but what about my data? What about that irreplaceable family photo you just uploaded yesterday? If the specific physical hard drive storing that photo was sitting inside Availability Zone A, was it just destroyed in the quake? Absolutely not. And here is the step-by-step of exactly why. When you upload a file, services like Amazon S3 do not just drop it onto one single machine and call it a day. The system automatically creates multiple copies of your data behind the scenes. It then takes those copies and scatters them across different, physically separate infrastructure, so your precious photo isn't relying on just one machine's survival. This built-in redundancy guarantees that even if one location turns into smoking rubble, a pristine copy is instantly ready to serve your request from somewhere else. Okay, so we've successfully survived a localized disaster. High fives all around. But we need to zoom out even further. What if an entire city experiences a disaster? What if a massive earthquake or a Category 5 superstorm wipes out all of the superhero headquarters in that specific geographic area?
Let's move to the next layer and see how this builds. To survive a citywide disaster, we have to scale up from a local level to a global one. It's kind of like Russian nesting dolls. We started with a single data center. We grouped a few of those into an availability zone. Now, we cluster multiple availability zones together to create what's called an AWS region. A region is a large geographic area containing multiple AZs. If one AZ fails, the region keeps working. But if a whole region is threatened, well, AWS has built a massive safety net for that too.
You see, AWS doesn't just have one region. They have a massive global footprint. We're talking active regions in North America, Europe, Asia, Australia, South America, and the Middle East. This means companies can deploy their applications across entire continents. For organizations that need the absolute highest level of resilience possible, they can essentially mirror their entire operation globally to ensure their data survives almost any earthly event you can imagine.
But wait, we still have a very practical problem here. If a user is trying to open a website that's hosted in a data center that just got swallowed by an earthquake, how do their devices actually know to go to the backup site? The answer is intelligent routing. This is essentially the invisible traffic controller of the cloud. It automatically directs user traffic far away from the unavailable infrastructure and seamlessly points them toward the healthy systems.
And this brilliantly illustrates the concept. Think of intelligent routing exactly like your car's GPS. You're driving along, minding your own business, and suddenly there's a major accident completely blocking the road ahead. Your GPS doesn't just blindly drive you into the roadblock, right? No, it instantly recalculates and finds a detour around the chaos. Intelligent routing recalculates the digital roads, ensuring your request completely avoids the destroyed data center.
However, fixing one problem usually creates another. If all that massive traffic from the destroyed Zone A is suddenly rerouted over to Zones B and C, aren't those remaining servers going to get completely crushed and overloaded by the double traffic? Well, they absolutely would if it weren't for our next hero, autoscaling. Autoscaling continuously monitors exactly how much demand is hitting the servers, just standing by, ready to launch brand new servers the exact second they are needed.
Think of autoscaling like managing a huge retail store during a sudden, totally unexpected holiday rush. Instead of letting your current staff get completely overwhelmed and burn out, you somehow magically hire temporary workers in a matter of minutes to handle the massive line of customers. And then, and this is the best part, once the rush is over and traffic decreases, you politely send those extra workers home. That way, you aren't paying for them when you don't need them, which, trust me, your accounting department will definitely appreciate.
Now, this intricate dance of routing and scaling is absolutely crucial because for many industries, downtime is literally not an option. We are talking about true zero downtime industries, banks managing billions of dollars, hospitals accessing critical, life-saving patient records, airlines coordinating flights in the sky, and emergency services deploying first responders. For them, even a few seconds of an outage is entirely unacceptable. For these ultra-critical operations, AWS provides advanced disaster recovery. Because applications can be continuously synchronized between entirely different global regions, it's exactly like having an identical, fully furnished backup office 2 states over. It has the lights on, the computers are booted up, and it is ready to open its doors the very second the main office has to close. You don't rebuild from scratch, you just flip a switch.
Okay, let's put it all together and summarize our 2 p.m. earthquake simulation. Step 1, availability zone A loses power in the quake. Boom, gone. Step 2, your data remains perfectly safe because redundant copies exist elsewhere. Step 3, intelligent routing acts as your digital GPS, instantly rerouting traffic over to the healthy zone B. Step 4, auto-scaling kicks in, rapidly adding capacity to zone B to handle the extra load. The end result? Millions of people keep streaming their movies, completely unaware that a natural disaster just took place.
Which perfectly embodies this thought. Sometimes the strongest buildings aren't the ones that never fail. They're the ones designed to keep working even when something does. The cloud isn't just one computer or one building. It's a vast global web specifically designed to outsmart chaos and keep the digital world running. It really makes you wonder, as we move further and further into this digital age, what other invisible safety nets are quietly running in the background, keeping our modern lives from grinding to a complete halt?